Hi, today we are going to discuss the design of a parking lot using a strategy design pattern. We will be using Python and my only goal for creating this video to get you prepared if you get this question in a low level design interview. I absolutely do not wish to discuss all the many basically components and hundreds of classes that are there in an actual parking lot system in real life. That is a pretty large system. I will be only concentrating on the low level design interview part. So the two things I am going to concentrate on. The first one is how you will do the requirements gathering and which features you will pick to discuss with your interviewer and which features you will leave out. We have to pick only the important features. Our time is limited in a LLD interview. The second thing is how will you explain your overall design step by step to your interviewer in a clear and simple manner so that you do well in the interview. So let's get started. Our parking lot is going to have multiple floors, and as of now it will park only either two-wheeler or four-wheeler vehicles, and there are going to be multiple parking strategies. That is, there are going to be multiple different algorithms that can be picked at runtime to pick the spot where a particular vehicle is going to be parked. So we will have our functionalities, then we are going to break the whole solution in multiple classes, and we will also see how you can implement the different parking strategies using the strategy pattern, and that will make it easy to add new parking strategies. And also finally we will have our Python code which we can run on this CodeZym editor and see that it passes all the test cases. One more thing, I wrote Java code for this question which was 170, that is 170 lines of code, while the Python solution was only 130 lines of code, 130. So basically if you are using Python in an LLD interview, it will be to your advantage because it is going to take less lines of code and you can complete your solution sooner. So let's get started with the requirement gathering part. Okay, first of all, how will we represent our parking lot? So it is going to be a three-dimensional array. The first dimension will be floors, and the next two dimensions are on each floor parking spots will be arranged in rows and columns. So this two-dimensional array tells you the basically blueprint of a floor. How, so if the value is 4, then there is going to be a four-wheeler vehicle parked at that point. If the value is 2, then a two-wheeler vehicle will be parked at that point, and if it's 0, then it's an inactive parking spot, nothing can be parked there. So this is what our basically each floor will look like in our parking lot. Since we have this clarity with us, so let's start it with the functionalities. The first core feature of a parking lot is you go there to park your vehicle. So you give a vehicle type that either I have a scooter or a car, that is two-wheeler vehicle or four-wheeler vehicle, 2 or 4. Then you have your vehicle number, which is your basically license plate number, and your ticket ID. For this question, let's assume you have a ticket ID generated for you, or you will generate your own ticket ID. Also, there are going to be multiple parking strategies as to how will we assign a spot to a particular vehicle. So we'll be revisiting this basically particular variable parking strategy again and again. We'll see. The second function is once you have parked the vehicle, later after some time you come and unpark the vehicle or remove the vehicle. There, generally you give your spot ID which is on your ticket where your vehicle was parked, but it may also happen that you may have lost your ticket, but you definitely remember your vehicle number, so you can give them that and they can basically remove your vehicle using that also, or you can give them a ticket ID, either of these three parameters, and your vehicle can be removed. Again, when you go to a parking lot, you might have seen in your office or any buildings, basically commercial buildings that you might have visited. On each floor, there is a display board which displays the number of free spots for each vehicle type. So we need to implement that functionality also. So there again, I have written the method signature for it, get free spots count for each floor for each vehicle type. Again, the same thing, if you may have lost your ticket and you may need to find a search your vehicle, or you want to see the previous data or historical data that last time where your vehicle was parked, then you can do that in a parking lot. We should have the search vehicle functionality. You give your vehicle number or your ticket ID. It can be your current ticket ID or from past, and it will return you the basically the spot ID where your vehicle was parked in the past or it is parked now. Now again, there should be actually functionalities for sending notifications to user, and there should be analytics and other features. Basically, user management should be there, admin panel should be there. But you know, there can be tons of functionalities like this in a real parking lot system, real world parking lot system. And the interview is going to be only 45 to 60 minutes. So we cannot discuss everything in such a small amount of time. So that's why I picked the first thing. Basically two things I want you to notice here. The first one is that I picked only the important features, and these are the features that your interviewer will want to discuss with you at least during the LLD interview. These are the important features that your interviewer will want you to discuss with you or deep dive with you. The second thing is I wrote the method signatures correctly. So this helps me clarify my thoughts. The second thing is, if the it makes it clear with interviewer what I am going to design for. So at this point, if they want to change anything, for example, they may want to introduce maybe parking strategy variable was not there and they may want to introduce it, then they can introduce it. Or they can just say, no, I do not want multiple parking strategies, I want only one, and I will tell you the custom algorithm for it. You have to implement it. If that is an interviewer who wants to see you code in the LLD interview, it may or may not happen. So these are the two things I want to take you through or you to understand. The first one is pick the important features for this question, and the second one is write the method signatures correctly. It will clear your thought and it will basically make it clear to the interviewer as well. So let's go and basically break whole thing in multiple classes. We are going to go bottom up when designing the basically different classes or dividing the system into different classes. So basically we'll start with the entity classes and move on to the classes that depend on them, and then go to one level up ahead till we reach the solution or the tester class. So the first class which a parking spot needs to have is the parking spot. It is the smallest unit of parking where a vehicle will be parked. So each parking spot will have a spot ID, which is floor hyphen row hyphen column. Basically, uh, a given row and column on a given floor. It will have a vehicle type, that which vehicle type can be parked there. It will be either 2 or 4 for when we are discussing this question. There is also we also need a status sort of variable. Is spot parked, whether a vehicle is parked there or not. Now, as we saw or discussed, there are going to be a two-dimensional array of parking spots on each floor. So class parking floor will represent each floor. It will contain two things. One is the 2D array of parking spot objects, and second will be a free spots count dictionary. Remember, we needed to implement the free spots count for each floor for each vehicle type. So what we did was, rather than counting each time going through the whole 2D array, we just kept the count here, right here, free spots count, so that we can fetch it in efficiently in a dictionary. The third will be, we also need to search for vehicles. Uh, Basically parking details, not vehicles. So for that we need a search manager, so that whenever a vehicle is parked, its parking details are basically indexed, and those details can be searched later at any point of time. Again, if you remember, there was a variable parking strategy. There are going to be multiple parking strategies for this question. Specifically, we are starting with two parking strategies. Do not worry about their algorithms, they will be similar. The purpose of a low-level design algorithm is to see how well you arrange your code, not how clever algorithms you use. So two algorithms will be there, simple ones, and we will have a class park manager, whose only job will be to basically park your vehicle. So what we do is we implement a strategy pattern. We create a single unified interface, which is parking strategy, which will have a single function park. It will take basically a list of floors and it will have a vehicle type. Okay, and based on the two algorithms, both of which will implement the park method, we will find the suitable spot and park our vehicle there. So we'll go through all these four classes, and finally we have our solution or the tester class, which tests all, and it will keep everything. It will keep the list of parking floors. Basically there are going to be multiple floors in the parking lot, so it will store all of them in a list. It will use them to park, unpark vehicle, get free spots count. Then it is going to be a park manager, which will actually have the algorithms to assign a parking spot, and then it will use the parking floor object to park the vehicle there. We will also have search manager where we will index the parking details and we will fetch them whenever we require it. So these are the classes that are going to be a part of our parking lot. Let's see them one by one. Parking spot class is simple. It's an entity class and you can just understand it. We already saw the three variables: spot ID, vehicle type is spot parked or not. So let's understand spot ID a bit. We already saw the blueprint for each floor. So now let's suppose this two-dimensional array represents our floor and the value parking 032. So this assume is already we are on the 0th floor and there are 4 rows and 4 columns. So 32 element is the third row, 0, 1, 2, 3, and the second 0, 1, 2. So this is our 032 element and its value is 4. So a four-wheeler vehicle can be parked there and its spot ID will be 0-3-2, 0th floor, third row, second column. So that's all about it, the parking spot. Parking floor class is the most important, you can say most important class in our design. It will have all the logic around which everything will revolve. So basically a floor will keep or implement it will have all the functionalities for that particular floor, basically park vehicle, remove vehicle, or get free spots count. It will have two core data structures. The one will be a two-dimensional array of parking spot objects. So it is also sort of a manager for parking spot objects. And again, it will also keep a map of free spots count for each vehicle type because we have to implement the functionality. During initialization, it will go through all the rows and columns in the two-dimensional array that we just saw, get the vehicle type, which is 2 or 4, and create a parking spot object that we just saw. Basically, floor-row-column is your spot ID, and it will increment the free spots count for that vehicle type by 1. Now, basically the final park will be called in the parking floor object only. So it keeps the data, basically it is the data store for all the parking spot objects. So our park manager will actually call this class to finally park the vehicle. Parking on a given floor, it's simple. Just go through all the, first check whether there is space or not. If there is no space, return. Else go through all rows and columns one by one and get the earliest parking spot, park the vehicle there, and increment or basically decrement the free spots count by 1 because we have parked a vehicle in a space. Parking floor also keeps the count of free spots in the map we just saw. So when this method is called, it simply fetches the count from the map and returns. If the vehicle type is not found, then it returns 0. It also removes vehicle. It checks whether the vehicle is there or not. If it is there, then it removes it and increments the free spots count for that vehicle type by 1. If you remember, we also have the functionality to search the vehicle. We implemented it in a class search manager. It does two things. It basically indexes your parking information or parking result information whenever a vehicle is parked, and then you can basically search that information. This query variable can be either your vehicle number or your ticket ID. So it keeps all the information in basically a dictionary or a map, you can say. So whenever the index method is called, two entries are made, one for vehicle number and one for ticket ID, and spot ID is stored against them. This is all there is about this. If you remember, in the beginning we had a parameter parking strategy in the park method. Let's see how we are. Basically, this parking strategy decides which algorithm is going to be used to assign a spot ID for a given vehicle. What we did was we created an interface or basically a super class which will have the method park, which will take a vehicle type. This will be implemented by all the algorithms. Additionally, it also takes a floors list or an array of floors, parking floor objects, which will be used to do the final parking because it is the parking floor object which has got access to all the parking spot objects. So to reserve, we need a parking spot object which is accessed by a parking floor object. We have two algorithms as of now. The first one is find parking strategy equal to 0, which finds the lowest floor, row, and column. So what it does is simply goes through all the floors and tries to park there. If it gets a suitable spot, simply returns the spot ID. The second algorithm is most free spots parking strategy. So it needs to find the floor with the maximum number of free spots. So it goes through all the floor, find the floor with the maximum number of free spots for that vehicle type, and calls the park method for that floor object. Gets the spot ID and returns it. Both these classes are going to be used by our park manager class, which keeps basically objects of both these algorithms. And when the park method is called, then based on the parking strategy variable, basically it is used as an index to this array algorithms. It picks up the appropriate algorithm object and calls the park method there. Both the algorithm methods are going to have the park method implemented because both basically follow the same parking strategy superclass. Benefit of doing all this is that the first one is it is very easy to add new algorithms. Why? If we need to add a new algorithm, all we have to do is add a new class and put its object here, and at runtime its park method will automatically be called. The second is now our classes have become small and basically so it is easy to read and understand code and easy to maintain it. Also, adding new code or adding new strategies doesn't affect any other classes other than park manager. It doesn't affect the existing algorithm. It doesn't affect the solution class or the parking floor class. Nothing. It only affects the park manager class, single line of change. Finally, let's connect everything using our basically tester class, which is our solution class. So it keeps all the vehicle types, it keeps the park manager object and the search manager object and the list of all the floors, basically parking floor objects. And for each of its method, it uses them. For example, for the park method, it calls the park manager and pass them a list of parking floors and the vehicle type and the parking strategies. If the vehicle is successfully parked, then it gets a non-blank spot ID. Then it indexes the basically parking details using the search manager that we saw and returns the spot ID. If, not if, when it wants to remove a vehicle, it extracts the floor, row and column from the basically your spot ID, which is simply converts it to int and splits by hyphen. And for the parking object on that floor, it simply calls the remove vehicle. That's all it does. For fetching the free spots count for that floor, it again has the floor object and it calls the free spots count there for the given vehicle type. For searching a vehicle, it simply forwards the query to your search manager, which returns the result. So this is the class which will be called by the different test cases. You have to implement the methods to this class only, and so that you can run tests. Now that we have completed our code, it's time to run tests on it. So let's select it all, Control A, Control C, and then let's go to CodeZym. This is question number 7. Java is selected, so let's select Python and let's paste our code here. All of our code, you can see that it is now on the editor. Let's hit the run button and run sample tests first. So it will run fairly quickly. You can see 2 test cases have passed. Let's submit and run all the test cases. And what I will do is as the tests pass, you can see that the status or the number of test cases was getting passed there. All the test cases passed. It took 5 seconds. I am going to put all the code on GitHub and put the link in pinned comments. So go watch that. This was all about the low-level design of a parking lot. If you are preparing for LLD interviews, or if you have your low-level design interviews scheduled in this week or next week, then you might have many questions like which topics should I prepare first, or which questions should I solve, because you do not have a lot of time and you want to prepare efficiently. So I will suggest the codezym.com/roadmap. It has basically all the short videos that you need to know for the interview. Basically what topics will be covered, what should you expect in LLD interview, how should you code, and basically the different questions, the most important questions first, the most important topics first. So it will help you prepare efficiently for your LLD interview. So do give it a try, and I wish you the best of luck for your interviews. Wish you the get the job you want. Bye.